All right, so the first question is asking for the units of rate, and the rate is calculated as molarity per second. Then we're wondering what happens to the rate when concentration of ammonia NH3 doubles. You can see between 1 and 2, it goes from 2 to 4, while the BF3 concentration stays the same. When the concentration goes from 2 to 4, the rate goes from 1 to 2, which is twice as much. So we could set up a little ratio here where we put the larger number on the top divided by the smaller one on the bottom. It's good to keep these as whole number values rather than fractions. So instead of doing 2 over 4 and 1 over 2, we would do 4 over 2 and 2 over 1. All right, with experiments 3 and 4, what happens to the rate when concentration of BF3 doubles? So when BF3 goes from 2 to 4 and ammonia stays the same, we see that the rate goes up by 8 times. Again, if we set this up as a ratio from 4 to 2, 4 from 2, we get 2, and then the rate of 8 over 1 is 8 times as much. Obviously, these are whole numbers, so it's not as challenging to figure out what those numbers should be, but if there were decimals, setting up that ratio is important. So now we want to look at how do we calculate a rate law for this reaction. So using the concentrations of each of the reactants and the rate information from the lab, we can calculate this rate law. So using the ratios that we did before, 4 over 2, 2 over 1, 4 over 2, and 8 over 1, we can figure out what the reaction order is with respect to each of the reactants. So for NH3, we do that concentration ratio, 4 over 2 to the x power is equal to the rate change, 2 over 1. So 2 to what power gives me 2? X must be 1. We do the same thing for the concentration of the BF3. So it went from 4 to 2, again, always doing that bigger number on top for our ratio so that we get a whole number rather than a fraction. So 4 over 2 to the y gives me 8 over 1. So then we have 2 to the y power equals 8, so y must be 3. 2 times 2 is 4, times 2 is 8. Then we use our values for x and y that we got above with those ratio calculations and write it as a rate law. Rate is equal to the rate constant times the concentration of NH3 to the first power times the concentration of BF3 to the third power. All right, if you have any questions, please let me know.